Hello viewers, I am Thompson Miner and today I will be presenting Lab 2, which is a revisit of Lab 1, which was about charge tapes. So the purpose of this lab is to further investigate the data obtained during Lab 1 by creating a more sophisticated computational model for calculating electric force and charge on the charge tape. This was achieved by modeling the tape as a line of charges instead of a point charge to account for the distribution of charges along the tape. Magnitude of charge on one piece of tape we found was 8.85 to the power of 10 to the power of -9. This is 4 times higher than the magnitude of charge calculated using the point charge model from Lab 1. So let's talk about how we came about these results. To start things off, these are the fundamental assumptions, principles, and assumptions. So we use the Newton's second law, which is force equals to momentum times mass times acceleration, and the Coulomb's law, which calculates the force due to an electric charge. The assumptions we had were each piece of tape had a charge of equal magnitude and distribution along the piece of tape. The tape acts as a point charge, their resistance is ignored. So these are the procedures that we did. We first had to charge the tape, and then first experiment was this, but basically this is what the experiment or that we are about to talk about today, and we are going to do a computational model of this. So our observations from the experiment, the magnitude of the gravitational force on tape B we calculated as this, and separation distance we measured as 0.02 meters. Charge on tape B, through our calculation, we found that it was this. This is the computational, a screenshot of the computational model. So some of the constants were the Coulomb's constant and the gravitational force. The mass of the charge tape was this in kilograms, and yeah, all this were prior results that we had, the estimated results that we had. So we first had to define what an electric field, where it would be the distances from everything, and coming to this section, we had to create, these are just specifications as to where the line would start and where the charges would be placed at. So we created our scale, which was 0.0001, so that it can be visible on one screen, and then we had to create a scale for the electric field vector on the top and plus the gravitational field vector. So these are all about that, and then for the tape measurements, these are for the tape measurements right there, and this was our result. So the magnitude of electric force we found was 1.3 times 10 to the power of -3. The magnitude of gravitational force, this was the gravitational force we found as 1.7 to the power of times 10 to the power of -3, and the magnitude of charge of one piece of tape was calculated to be 8.85 to the power of -9, which is way different from our first results. So for the discussion, the computational model and real-life experiments will always differ due to gravitational force and electric force are not always equal due to gravitational force and electric force are not always equal in real life. Sources of error, the pieces of tape did not necessarily have equal charge distribution because they never, sometimes there's no guarantee that charges will be distributed equally, and mishandling of the charge tape could have resulted in some loss of charge. So what if you had a model each of your tapes as a single point charge, like in the previous labs? So the electric charge due to the point charge when the previous lab we found as 1.9 times 10 to the power of 8. electric charge due to the line charge model we found as 8. Today's lab we found it as 8.85, calculating it as line charge. Why do they differ? It's because the electric charge due to the line charge model more accurately represents real world values, because charged bodies aren't point charges, rather they contain point charges distributed along the surface. Thank you.